Hello and welcome to Flipcast number 6. This one is systems thinking across a variety of disciplines. And as you're beginning to realize by now that the systems approach is common to many disciplines. For example, economics, geography, politics, ecology, and so on. There's a similarity between the ways in which matter, energy, and even information flows not only in biological systems but also in transport and communication systems. Here's a systems diagram that shows a small part of the carbon cycle. Let's start here with carbon dioxide in the atmosphere, which of course is absorbed by a corn crop. The carbon dioxide goes into the stomata on the underside of the leaf, eventually finds its way into a chloroplast and then transformed by photosynthesis, and certainly makes sugars and starches and so on. Then the next stage, as you can see in the diagram, the corn is finely ground between two rotors, and the component sugars are separated. Those sugars are fermented with yeasts to release alcohol, and then the alcohol is purified by a process of distillation, shown here. And that alcohol can then be used as an alternative fuel. This is very common in countries like Brazil, for example. And then, analogous to aerobic respiration, the fuel is burned in oxygen and carbon dioxide is released, so completing the cycle. And shown here is a crude but classic model of the circular flow of money and goods and services from individuals and businesses across markets. And here's a very famous curve in economics, the supply and demand curve. You can see when supply exceeds the demand, there's a huge surplus, and of course when the demand is much higher than the supply, then there's a shortage. And you can see where the two lines intersect, there's an equilibrium point. An equilibrium is something that we're going to meet again in environmental systems and societies. Here, more or less for fun, is a pyramid showing Bill Gates and the world's 487 other billionaires at the top of a wealth pyramid. The brown section is the world's 1.2 billion middle class. One reason I'm showing you this is that later in the course we'll be looking at pyramids of energy and pyramids of numbers in food chains, for example. Here is a systems flow chart. We won't be seeing many of these in the course, but it's interesting to see the logic going from start to end and the parallelograms for inputs and outputs and processes lying in the middle. We can imagine, for example, in photosynthesis, the input being solar energy, carbon dioxide and water, and the outputs being sugars and other food products, and the famous waste product oxygen, which ends up in the atmosphere. Here's a quick diagram to illustrate that process. So next, take a look at the systems approach on the website. Let's click on there. And a couple of things I'd like you to look at. First of all, when we come back to class, there are a series of essential questions. Look at this. A systems approach involves thinking holistically in terms of inputs, outputs, and processes. And for each of the following systems, I want you to construct an annotated diagram displaying the main inputs, outputs, and processes. As I said before, use labeled boxes rather than time-consuming, elaborate illustrations. There you can see I'm going to challenge you. Perhaps it's easy enough with the redwood tree, just a variation on photosynthesis. But what about making a batch of pancakes from scratch, or using your own TI-84? And lastly, while you enjoy an image that evokes the famous Chilean sea bass case study we will tackle in the near future, I just wanted to say, be careful out there.